All right, so let's talk about analyzing relationships. Last time we met, we had gone through an exercise where we read some requirements for a university, and there were all sorts of things in there. There were some courses and some faculties and some students, and faculty assigning grades to a student, and students enrolled in a particular department. And this is our first approximation of what that UML class diagram looked like. We listed all the nouns, we listed all the verb phrases. So let's revisit this class diagram and see if it meets all the requirements. We'll also consider what if you interpret the requirement this way or interpret it in some other way, right? And see how that affects this class diagram. And so the intent is that for the first assignment is that you apply similar thought processes where you come up with a first approximation of what the class diagram might be, and it's common that everybody will come with a different class diagram than someone else. It's not uncommon, and you're just going to start reading through this, and the way you interpret it will drive your train of thought on how to optimize this or changes, evolve this class diagram into your final version. So we'll look at the relationships that connect the various connections, right? So these relationships here, right, saying that a student is issued a permit, that a student graduates in a year, that a section is offered in a particular year, a course has many sections, a professor teaches a section. So we want to analyze these relationships, right? Those are driven by the verb phrases that we had identified, right? So and verb phrases sometimes are hard to interpret because the verb phrase might have multiple verbs, right? And so and sometimes they're not necessarily binary, where you only have two nouns related, but you might have 3 or 4 nouns related in the same verb phrase. So depending how you interpret it, how you parse it, right, it might yield different class diagrams, right? So let's take a look at them. So in this one, some of them where it says majors in a particular department or enrolls in a particular section. So section seems to have many relationships, right? One in a one-to-many to departments, and a many-to-many to sections, in a one-to-many to courses. So the student has many relationships with many other classes. And so we'd like to be able to consider, what if scenarios on how you might have interpreted something, right? So for instance, something that might have been a legitimate way of interpreting the phrase that a student is enrolled in a course. Student is enrolled in a course. We might have come up with something like this. This might be a perfectly fine interpretation, where it says a student is enrolled in a course. And you might say, well, actually, no, a student might be enrolled in many courses, right? And a course might have many people enrolled in that course. And then it says, oh, wait a minute, but there's a section around here. So track that there's many sections for that one course. So you might hand it off on that side, and this might be a completely reasonable way of interpreting this, right? But once you start analyzing what you just drew, you notice that there's no way for us to capture the fact that a student is actually enrolled in a section. And keep track of that students are grouped in a section, and then the section belongs to a particular course. Right, that this diagram is, it's inadequate, right? It's not allowing us to capture what we need to capture. Right? We know that there's many sections in that course. We know that the student is in that course, but there's no way with this class diagram to know which student is in what section and what are the students in the entire section. Make sense? Right? Even though this might have been a completely reasonable class diagram, so you have to be careful. Am I reading it too literally? Am I reading the paragraph or the verb phrase too literally, right? And that is inadequate. So you need to be able to, English is not, no language is perfect, right? And it's always subject to interpretation, right? So you need to interpret and says, is this what you meant? Right? Is this what you meant? What the class diagram was meaning to be captured? So you need to go through every single path. Through those lines that connect the classes, and see if you're looking for these inadequate diagrams, these relationships. A couple more things here. if we go through student receives grade, right, and then the professor assigns the grade, and the professor teaches the section. Notice that there's no way to know that that a grade was yes, it was assigned by a professor, but while they were enrolled in a particular section, right? So there's no way of knowing that yes, that's my grade, but I don't know for what section. So we kind of somehow miss the fact that the grade was for that particular section. So you're always looking for these inadequate relationships. Obviously, these inadequate relations were added on purpose so that we can have this discussion. And the reason these inadequate relationships might happen is that maybe we parsed the verb phrase wrong, right? We literally looked at student receives grade in a binary relationship when it actually was a three-way relationship between students, the grades, and the section, right? That the student receives a grade for an enrolled section. Well, the professor assigns a grade, professors to assign grades to the students in their particular section. So it's a three-way verb phrase as opposed to a binary relationship. So you have to make sure, right, that you know who's involved in that relationship. So for instance, let's consider this one where you have students receives grade, where it's missing that it's for a particular section, that it's not binary, but it's three-way, right? In a UML class diagram, the way you would capture that is like this. Maybe you have maybe a dot there and say that the relationship is three-way between the student, the section, and the grade, and you're done. From a UML's point of view, this is totally fine. Okay, but when you're going to implement it in Java or you're going to implement it in MySQL, you can't implement that dot. There's no equivalent for when you to build it or construct it or represent it formally in any language other than this conceptual graphical representation, right? So you need to convert it into something concrete, right? Whether you're going to implement it in MySQL or in Java or C# or whatever it is, or JSON. Right, so going from this conceptual representation to this concrete representation, we call it reifying, right? To reify, to make something concrete, to go from something conceptual to something concrete that I can implement. So now this is implementable, right? We can have an additional class. Notice that we're substituting this verb. We're substituting this verb by equivalent nouns, right? An assignment. I am assigning there's a grade assignment that relates for all three, the students, the sections, and the grade. And then I put in how many are related. How many students, how many sections, how many grades are assigned to each one of them. The one to many, the many to many, the many to many sections, right? And here we'll come back to this a little later. Notice that in this diagram it was very specific how many are enrolled in this relationship, right? There's for any combinations of student with section or section with students, there will be only one grade, right, assigned for that combination. When you go to this implementation, you kind of lose that implied constraint that for the combination of student and section, there's only one grade. Here, this would allow me to put for the same combination of student and section different grades, which make no sense. Right? So you have to be careful, right? That when you reify, you kind of lose some of the original constraints that you had in UML that you cannot enforce anymore. So you need to perhaps go a little further. Now this is somewhat a hint that this eventually this class will become our enrollment table, right? Eventually. So we replace receives with grade assignment, and so here's formally the description of what reification means to convert from relationships to classes, from relationships to classes to nouns, basically convert what used to be an action into a noun, right? And then it converts something that is easy to represent as many binary relationships. So the three-way non-binary relationship of students, sections, and grade was converted into multiple one-to-many relationships. Yes? which is indeed easy to implement. So something that's not implementable is implemented into multiple binary relationships. So three-way or four-way relationships is substituted by multiple binary relationships. Applying that transformation, we replace the grade and the section and put a grade assignment that relates the section, the professor, the grade, and the receiver, who receives that grade. Yes? All right, so we've reified from top to bottom. Also, obviously, you would do that over and over, looking for multiple instances of these inadequate relationships. You're also looking for redundant relationships, meaning, ideally, when you are retrieving data from the database, there will be one specific query that will give you your response. Right? There won't be multiple equivalent queries that from where you can extract the same information. Right? If there are different ways of being able to query and retrieve the same information, that means that there's redundancy in your database. Right? And remember, redundancy breeds inconsistency. Right? That eventually, maybe at the beginning, perhaps you query one way and you query some other way, and they're both the same. You get the same result, and that gives you confidence. After a while, it might be that the data, when you follow one path and you follow some other path, right? The data will drift away from each other, right? And inadvertently, by people entering or mistyping something, and there's no way for us to validate or enforce constraints, right? So if you have different ways of querying it, there is redundancy. Careful, it's a red flag for inconsistency. So notice this query. All sections a student. I want to retrieve all the sections a student is enrolled. So looking at that, there's a couple of ways that I can achieve and retrieve the data for all the sections that are enrolled in a section. I can query it. I can notice whenever you have these cycles, right? You have to be careful, right? That if I want to be able to retrieve all the students in a section, through this assignment, I could navigate maybe going this way, or I can assign just from here to here. Right? So traversing this from here to here, right? It's kind of redundant of going out this way. I can answer all the students that are enrolled in a section using this relationship, or I can use this other relationship, going from students receive a grade to a section. Whenever you see kinds of things like that, you need to ask, do I need both? Do I need both? Right? Maybe you do. Right? But if you don't, you should decide which one you're going to keep and which one you're going to remove. Right? Because if I query it this way, it will tell me all the students in a particular section. But here's another record that's going to tell me the same thing. Right? That, hey, you got a particular grade for that student enrolled in that section. What if I inadvertently remove this, right? Or add a relationship that is not representative here? Okay, that some student, I might say that some other students enrolled in the same section, but is not enforced through here. So there's no way to verify these two things. Right? So you might be adding inconsistency. This is an example. Right, you can go from student to section, or from student grade assignment and section. You might update one path but not the other. So that introduces the inconsistency. So here we've decided to remove one side of the relationship. We say we're just not going to do it. Once you think about it and you say, wait a minute, do I need to keep track of who assigns this? The grade? Right? If one of the rules is that a professor is the only professor who teaches this section, then who else could assign this grade? Only the professor. So it's not needed. Right? You say, well, there's no need to keep track of who assigns it because you're the only professor in that section. It could not be anyone else. Right? So it's safe to remove any of these redundant relationships. Right? So we remove that. Or another query might be that I want to retrieve and see what are all the students that enroll in a particular department. Okay, and you might find, again, whenever there's a cycle, right, it's a red flag that you should consider. So you need to traverse. Based on all your queries, you ask yourself, well, is there redundancy? So I can retrieve the list of students in a major by traversing from department to students or from students to department, and I can certainly do that. Or I could traverse the other way, students to grades, to sections, to course, to department, right? And you might ask, well, can I remove any one of them? Right? And it turns out that no, I can't. I need both of them. I need to be able to, if I remove one, I cannot get the same information from the other. So I need to keep both of them. Now notice that what I said, right? Something is redundant, right, or inadequate only when you know what you're querying for. Right? So the use cases, when you define the use cases for a user, that will define for you all your inserts, all your updates, all your deletes, all your select statements, right, of how you're going to implement all those use cases. Once you know your query and the data model that you have there, right, you're going to, for each query or your select statements, you're going to ask yourself, okay, look at having the class diagram that I have so far, is there redundancy? Right? Only when you know what the query is can you ask yourself, is the class diagram redundant, right, or adequate? If you don't know your queries, you won't know whether your class diagram is redundant or inadequate or anything. Right? It is the use cases that tell you whether your class diagram is valid or not. Okay? The class diagram is not valid in a vacuum. It has to be driven by the use case analysis, because it might be that you implement and you find, based on all your select statements and your queries and your updates and you delete, that there are no redundancies in your class diagram. But later on, 6 months from now, the requirements change, right? And you need new updates, new deletes, new inserts, and new select statements. Now the class diagram, based on these new requirements, now it is redundant. Right? So there was nothing really wrong intrinsically about your class diagram. It's only in the context on what the queries are going to be. Make sense? Right? It's only within the context. All right. So having removed the professor, we decided that we don't need to keep track of this assign, and eventually professor is going to be sucked into the section, I believe. Right. So up to this point, I don't believe we have any many-to-many. Yeah, we don't have any many-to-many. But let's introduce a many-to-many as if we had a many-to-many. Right. So for instance, right now we have a student enrolled in one department. Right. So one department can have many students. Many students can be enrolled in one department. But say we change the requirement and say that actually a student can be enrolled in many departments. In many colleges, we say you can have a minor in one department and a major in some other department. Right? So say we allow that. So if we allow that, again, there's no mechanism for us to implement this in a relational database. This is perfectly fine in a UML class diagram. That's perfect. You don't have to do anything. But if you're going to implement it in Java, or you're going to implement it, well, actually in Java you could, right? You can have an array on one of them and an array on the other, right? And they both have pointers to each other. Right? You can have an actor class having an array of movies, right? Of all the movies that actor is acting in. Yeah? And on the other side, you can have, in the movie class, you can have an array of actors. All the actors acting in that movie. That's still perfect. So this is totally fine, implementable in Java, in JavaScript, in JSON. But in relational database, you cannot implement this. Right? A field, a record for an actor, there's no way that you can have a field pointing and referencing many movies. Right? A field cannot have more than just one value. Right? Same thing with a movie. You can't have a field pointing to all the actors. So this is not implementable in a relational database. Right? So we need to reify it. We need to make it concrete. So to make it concrete, we replace the one many-to-many with several one-to-many relationships, right? So we have a student major that says, what student is enrolled in what department, and that's perfectly fine. Right? That now we can implement it in a relational database. So we reified it without the many-to-many. We just replaced it. Let's go a little further though. Let's say in the original implementation where you had one department and many majors, right? And say you were keeping track of the GPA, right, the major GPA, and said, well, this student, is enrolled in a particular department. The GPA can only be for that department, right? It can't be any other department. That's the only GPA. But what if you now belong to many departments, right? Notice that now that you belong to many departments, the GPA would also have to be many to many, right? I need to keep track of the GPA for each one of those departments. Yes, but notice that the class diagram is no longer valid. Right? Over here, it was clear that GPA could possibly only be for that department. But now you have this many to many doesn't tell me what GPA belongs to what department. Right? It's in the wrong place. Now it has become it has come from being a binary relationship into being a tertiary relationship. You need to tell me this GPA is for this student in that department, right? So we need to move it somewhere else, right? We need to move it so that it becomes a three-way relationship, saying that, hey, based on the combination of student and department, once you know which department and which student, well, there's only one GPA for that combination of student and department. Now, obviously, that's conceptually fine in UML, but we need to reify it, right? We need to convert it into something that replace that many into several one-to-manys. We have into the student major that replaces that verb into a noun, and now we know that based on the combination of department and student, you have that one GPA. Make sense? Now, what if you go a little further and says, well, I might not be enrolled, right? I might be undecided. Okay, so I'm not enrolled in any department. But there's only one department. Like if I do enroll, there's only one department that I belong to. Okay, so that GPA on the left-hand side now becomes also 0, 1. The record might exist, or the record might not exist. Right? If I am enrolled, then I do have a GPA. If I'm not, if I do enroll, I have a GPA. If I'm not enrolled, I don't have a record for my GPA. Make sense? So that's perfectly fine. But what if when you go to a many-to-many on the right-hand side, where you can be enrolled in multiple departments? Now again, we're going to have the same problem. We're going to have to move the major GPA under and become a three-way relationship again. Yes, but it's slightly different because the relationship between the student and the department is optional. Meaning, I might not be enrolled. Okay, so the just moving it under there is not enough because the record might not exist at all, right? If I'm not enrolled, right? So how do we capture that? So the way to capture it is to have the optional over here between the student and the student with the major. We still have the reification, but notice that this 0, 1 means that maybe none of this exists, right? I might not have a record at all with the department, and I might not have a record at all with the GPA, right? If I am enrolled, then yes, I have both a reference to the department and a reference to the major GPA. Okay, so that's how you would capture that. So the optional. Let's take a look at the optional annotation. Perhaps by considering the permit over here. The permit, depending on whether you're a student, a faculty, or whether you're a part in the university, that's an optional record, right? So none of this might exist. Right? I don't have a record for you for the permit. It says I don't have a record for a permit. I don't have anything. I have no license plate, car, or anything. Right, so let's take a look at that. Right, where you have a student. That there might be a relationship between the student and the permit, and depending perhaps if you are a faculty or not, this might expire. You might have an expiration date. Keeping track of that. If you're a student, perhaps it expires every semester. If you're a faculty, maybe it just never expires or expires several different years. Yes.
But that question about the student and GPA, I feel the relationship with many students have one GPA. I don't have one.
Many students? Where? Here?
Yeah.
No, what you're saying here is that one particular student, right? If they enroll in a particular department, then they might have a record in here, the student with major referencing the department and referencing the GPA. But there's only one student.
I mean, the left side, the GPA one is many students. The left side.
Oh, yeah. So you might have the same GPA, right? So many students can have the same GPA. Like I have 4 and you have 4. Reify, strong. Right. So strong are when you explicitly have a one record having references to another record that they both have to exist. That you might have a permit regardless of anything, right? So if you're a student, you have a permit, right? So this is being captured like this, where you have a record student. You might have the permit, maybe you won't use it, but you have the permit anyway, which presumably enrolls you into. You have to provide a car regardless of anything. You have to tell me. Now, somebody had mentioned this that when you have these strong relationships, sometimes the argument is that, well, why don't we just have the other record just be part of the parent record, right? Where the permit information for a student has been sucked into the student, right? If aren't they part of the same thing? And again, this depends on whether it conceptually makes sense. Or if you want to keep track of them independently of each other, or if you might decide to make a compound data type. Very much like we decided that the class professor was not important enough to keep track of a separate class. We decided that if you're only keeping track of the username of the professor, then it might as well just be a field in some other class. Yeah, that's a perfectly fine decision to make.